Today, in this session, we'll be discussing about the past papers and term test papers part related to your structure and bonding lesson, especially the first two parts, right? How to draw the most acceptable Lewis structure and then resonance structures, right? So this is the questions discussion of the resonance structures lesson, right? Resonance structures lesson. So the last day we learned what are the resonance structures, right? And so related to resonance structures, we have to discuss the questions, right? More amount of questions. So we discussed 2012 question and we discussed 2016 question. So then here we will be discussing more questions. Before that, I think all you have received your O-level results without any issue, right? So then first of all, congratulations on your performance, on your results. I hope all you have taken very good results or your expected result, right? If there's any doubt related to any result, you can apply recorrections and then you can go through with your screen, right? So now if you are searching for A-level science, there are two options, mathematics and bioscience. So then you can do and continue what we have done, right? If you are changing the stream, that's also possible because you haven't attended to a school yet, right? You can move to arts subjects, tech subjects, or commerce subjects. There are options available. But as I guess, or as I think, as I believe, the best stream to do A-level, I mean, for a certain student, the standard stream, the best stream is A-level maths or A-level bioscience, right? So then try to do, okay? So then definitely we'll give a good guidance to you. Do not worry about chemistry. If you are attending our classes, I can guarantee by teaching and all your results. Also, if you are doing properly, if you are engaging properly with us, right? Don't need to keep any worries. So then try to manage the other two subjects. So you have taken results for 9 subjects, I think. 9 subjects. So in A-levels, you don't have 9 subjects. You just have 3 main subjects and 1 core subject, sorry, 1 optional subject, which is general English. So generally we say A-level results in 3s, right? 3 A's, 3 B's, 3 C's, likewise not 9 A's, right? Then your target should be 9 A's to 3 A's. In 9 A's, 3 A's correct. Subject no, the workload is high, right? So then you have to have the same dedication, or you have to have a maximum dedication than your O-level result, right? Question. So then if you have taken science and maths A passes, that's just enough for A-level science or A-level maths, right? Or A pass or B pass, right? Even you have taken a C pass for A-level, O-level maths or science, you are eligible to do science. That's no issue. But there are some schools that are selecting students that they have scored A pass for maths, B pass for science. Likewise, there are some criteria. But generally, if you are doing your A-levels in the same school, you can do, right? You have a C pass, right? Okay. And then if you're trying to change your school, that's an option, right? You can change your school, you can apply to new schools, Columbus schools or some city center schools you have in your city. So then try to attend to those schools also. That will be a good experience and good opportunity to you to get a new experience, right? Okay. So then the applications are available from next Monday. You can buy them from bookshops, or sometimes from the school that you are going to apply, you can buy. Like as an example, if you are going to apply to just in Southlands College School, so then the applications will be available near the school. Most of the times, the bookshops near the school, or otherwise inside the school, there's office. So then in the office room, there will be applications available for another students. Then you can get one and apply. For school students and other schools, there are 2 interviews. So then they will be selecting you if your performance is good, right? So then if you have done general, English literature, that will be an added advantage. Okay? And if you have certificates for some performance, island-wide performance or zonal performance or divisional performance, they will be giving marks in school admissions. Right? Again, A-level interview will the marks, certificate, right? zonal performance, sometimes provincial performance, and then all island performance. Those certificates, you will be getting some marks. If you are a scout, also there's a chance, right? So likewise, there are some options. So then try to have it, right? So when I'm telling about my experience, definitely, I had the best opportunity to attend a very good school in Colombo district from a rural school, right? So then that was one of my major breakthroughs in my life, as I believe my O-level result and my A-level school. So then definitely that's one of the best decisions I have taken, right? So I'm requesting you, if it is possible, if you have the luck, you also can try that. I'm not telling that school will teach you really well, education is 100% best, not that thing. Sometimes you will be getting a good competitive background, competition from your friends, right, than the previous school. And then you will be getting a good social circle after you have left the school. You have good colleagues who are doctors, engineers, bankers, or lawyers. So then you have more connections. And that is very important when you are living as a senior or adult, right? Okay, that's my view about your results. So then definitely if you are doing NL maths or science, right, just try to work really hard than the other students, commerce, art, tech students. If you can work hard with us, you can do some dedications, definitely we can move to the results that you expect, right? Yes. If you have any questions, you can ask from me. Because I have discussed about that. Right, okay. B pass second school have change current depends on the school that you are going to apply. Most of the times, when a new school, when we're interviewing new students, we are checking that they should have A passes for both maths and science. Okay. Initially, we check 9 A's. Then if 9 A's are not available, we check 8 A's, but science math A passes. Then 7 A's also possible, but science maths A passes. That's the criteria. Okay. Okay. ඒ වගේ ඉතින් criteria තියෙනවා. Just we can apply like up to 6 schools. ඕන තරම් ඉස්කෝල ගානකට apply කරන්න පුළුවන් because application forms are available. Like 6 applications, 10 applications. මම applications 6ක් දානවා. ඉස්කෝල 6කට. 6කටම යන්නේ නේද? Right. So that's what you have to do. You have to get a result sheet and you have to prove it from your school principal, and then you have to get the application and you have to fill it and just give it to the new school. That's it, right? School එක gate එකට ගිහිල්ලාම submit කරන්න. ඔක registered post දාන්න එපා. school එකට ගිහිල්ලාම දෙන්න පුළුවන්. සමහර post කරනකොට interview start කරලා ඉවරයි. school එකට ගිහිල්ලාම office එක අතන තියෙන letters ගන්න තැනක් එතනට දෙනවා. ඒක අරගෙන school එක පිළිවෙලට යවනවා interviews. සහ ඔයගොල්ලෝ යන්නේ school එක. The school that you are going to attend, the new school, if you have some connections, I mean teachers or any other personnel, so you can get a communication, good communication when the interview is there, right? And then what you have to bring, likewise. Okay? You can attend to that school using those connections. I'm telling you can get a good communication about the things, right? Whether you have an application was received or it is taken, likewise, right? So then do not give up that idea, but keep that idea. Sometimes I have seen even after starting schools, even after like 3 months, students are moving to new schools. ඔය ඉස්කෝලේ පටන් අරගෙන මාස 3කට පස්සේ සමහර ළමයි යනවා ඒ ඉස්කෝලේ. අලුත් ඉස්කෝලේ, වෙන ඉස්කෝලේ. There are chances because the vacancies are available. The students who are said they have not attended the school. So there are vacancies, so they are filling the students again, second round, third round, likewise. Okay. Now we were discussing Lewis structures. So under the Lewis structures part, under the Lewis structures part, we started discussing past paper questions. So 2012 question, 2016 question, right? So now I'm going to discuss 2013 question, right? The application forms are not available online, right? Always some schools available, major schools are PA somehow, but school එකට ගිහිලා ගන්න ඕනේ physically ගන්න ඕනේ නැත්නම් bookshops වල තියෙනවා, right? ඒවා අහලා බලන්නකෝ bookshop එක, right? past papers and term test papers. So then in this one, let's discuss 2013 question at the beginning, right? So you can see here, this is the first question we are going to discuss. So I have added the tutor to your WhatsApp group, right? So I think last day you couldn't do any homeworks because I have received your results, right? Okay, so I can understand. This is nitramide is a weak acid. It decomposes to this species. Skeleton is given. Draw the most acceptable level structure. So please write the question. If you haven't done the question, okay, just write the name of the molecule, draw the structure, and write this question, right? And keep 5 lines, right? Keep 5 lines. I'm going to discuss the question, right? Keep 5 lines for this after writing this. Okay. Keep 5 lines. Okay, Putala, let's start. So then this is how to start. First of all, we'll count the electrons. You can do with me. First of all, let's count the electrons. So when you count the electrons, we know the number of electrons is equal to the group number, right? So when you consider hydrogen, the group number is 1. There are 2 hydrogens, right? So it's 2. So from nitrogen, how many electrons? There are 2 nitrogens, right? So nitrogen's group number is 5. 1 nitrogen will give 5 electrons. When there are 2 nitrogens, 5 times 2, 10 electrons. And here oxygen, right? So 1 oxygen, 6, right? Group number is 6. So there are 2 oxygens, 12. Then take the total number of electrons. Total number of electrons. So then this is 12 plus 12, 24. So this is 24 electrons. So you can take electron pairs. So actually the electron pairs is 12. But every electron pairs can 12 kg. So from the electron pairs 1, 2, 3, 4, 5, you can subtract this 5. Right? So 12 minus 5 is 7. Then there is remaining electron pairs. So what you have to calculate the remaining electron pairs, right? You have to calculate the remaining electron pairs. That's a must. Can you understand? So after calculating the remaining electron pairs, you have to put the electron pairs around the atoms. Generally, 3 non-pairs can be kept around a single atom, and it is nitrogen and oxygen. But for hydrogen, you can't keep any non-pair, right? So then we have to keep 7. 1, 2, 3, 4, 5, 6, 7. Likewise, okay, just up to here. If you have not done, you can do with me live right now. Okay, so then please calculate it by a side, remaining electron pairs, right? And then draw the skeleton from the pen, then get the pencil and eraser, then put non pairs as I have taken. So if you have done, you have to wait, right? I'll show the marking scheme, but I'm explaining the method also. Right, okay. So actually, if you haven't watched the last day's session, I don't know whether new students are watching this one. If you haven't watched the last day's session, definitely you have to watch it before this. Because the theory part of this lesson I have explained last day, deeply I have explained. And if you are watching that part and this one, that is complete. But if you are starting with this session, there will be a problem. Now it's okay, you can just watch it to get an idea. It's okay. But try to watch the previous session definitely once, right? Okay. So then after this, what I have explained, what you have to check. Right? You can start with by a side, right? You can start with a side, and you have to check two factors. What are the two facts you are checking? What is the first fact? Can you remember? For carbon, nitrogen, oxygen atoms, we have to check one fact. Okay. Number one, okay, octet. Octet. So what is octet? We have to check whether there are 8 electrons available or not. Electrons attack innavada nadda kiyala balanna. Right? We have to see whether there are 8 electrons available or not. That is called checking the octet. Checking the octet. Right? So if there are 8 electrons available, you don't want to worry. But if there are no 8 electrons, if there's like 6 electrons or 10 electrons, you should make it 8. 10 නම් අයින් කරන්න ඕනේ, 6 නම් add කරන්න. Right? By as bonds all on. Next thing is charge. You have to check the charge. Right? You have to check the charge. So how to check the charge? Right? How to check the charge? You know, when the number of individual electrons is equal to the group number, the charge is 0. The number of individual electrons is equal to the group number, the charge is 0. So you have to see whether there's any charge available or not. Most of the times, what we have to do, we have to minimize the charge. Any charge එකක් තියෙනවනම් charge එක නැති කරන්න. හරි? Charge එක 0 කරන්න. We have to make the charge up to 0. That's what we have to do. Right, okay? So let's check it. This oxygen. This oxygen. So how to do? 2, 4, 6, 8. Right? 2, 4, 6, 8. So we have the octet. Do we have any charge here? Do we have any charge here on oxygen? Yes. Why? Because there are 7 individual electrons. Check the individual electrons. 1, 2, 3, 4, 5, 6. From this one, we get 1 electron. Oxygen is in group 6. There are 7 individual electrons. That means which charge we get? We get a minus charge. But we don't mark the minus charge. Why? Because we have to minimize it. We have to minimize it. We have to make it 0. In order to make the charge as 0, what we do? How to make the charge as 0? We can erase the lone pair and add a bond. We can erase the lone pair and add a bond. Now see what will happen. Octet. Do you have the octet? Yes, 2, 4, 6, 8. Octet is there. What about the charge? You can see clearly we have 6 individual electrons. 1, 2, 3, 4, 5, 6. That means charge is also 0. So then this oxygen is completed. Then oxygen mission is completed. Right? Octet is there, charge is 0. That's our mission. Octet available, charge 0. That's the complete mission. Always we are trying to make octet available even there's any charge. But related to charge also, we're trying to make the charge as 0. Not allowing any positive or negative charges. But there are some issues that we can't have 0 charge. In that events, we will have a charge either positive or negative after completing an octet. After completing an octet. There? Right, okay. So then this nitrogen. Check the octet. 2, 4, 6, 8. So how many electrons we have? We have 8 electrons. So octet is there. Right? Octet negative. What about the charge? Right? So then do you have any charge here? Can you give the answer, right? So you know nitrogen is in group 5. So that from here 1, 2, 3, 4. Nitrogen is having only 4 individual electrons. Then there's a positive charge. There's a positive charge. So then can we make it 0? Positive charge means it needs more electrons. It should get more electrons. Isn't it? Nitrogen is having a positive charge currently. So can we remove the positive charge? I mean, can we increase the number of electrons? Yes. Increase කරන්න පුළුවන්. එහෙම පුළුවන්. You can erase the lone pair and make a bond. Now, how many individual electrons? 1, 2, 3, 4, 5. You have 5 individual electrons around nitrogen now. Now the charge is 0. But this is incorrect. Why? Now the structure is totally incorrect. Right? Why? What is the reason? Can you find out? Octet. You can't lose the octet even you are having a charge. Charge ka kavat octet nathi karaganda. Right? Octet is a must. Charge is optional. Making the charge 0 is optional. Keep remember. It's not compulsory. Octet is compulsory. So, I'm moving back, right? Erasing the bond, keeping the lone pair. So you can understand we can't make the charge of this nitrogen as 0. We will lose the octet. So we will mark the charge and go away. Right? Charging a marker, plus. So you should understand this is a neutral molecule. Question 13 level question. So if it's a neutral molecule, if you get a positive charge to a certain atom, definitely you should get a negative charge to another atom. Then the molecule will become neutral, isn't it? Yes. So then here, 1, 2, 3, 4, 5, 6, this is neutral. So this is negative. So when nitrogen is getting a positive charge, you can see oxygen is getting a negative charge. Nitrogen is positive, oxygen is negative. Clear? That's really important. What about this nitrogen? So when you check this nitrogen, you can check the octet and charge. OC. Octet 2, 4, 6, 8. Charge 1, 2, 3, 4, 5. Charge is 0. That's the event. That's the event. Is it there? So can you understand the situation now? This is the most stable structure for HN2NO2. So if you want, you can confirm the number of electrons by counting total electron pairs. Count the total electron pairs. Count bond pairs and lone pairs. Says under 7 lone pairs there. Count 7 lone pairs. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. How many total electron pairs? Total electron pairs kiyak තියෙනවා? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Total electron pairs is 12. ඔයගොල්ලෝ හිතන්නේ remaining electron pairs හැම වෙලේම 7 වෙන්න ඕනේ. නෑ, එහෙම වෙන්න ඕනේ නෑ. The remaining electron pairs, this is initially we are calculating. Right? මේක ඊට පස්සේ වැඩක් නෑ. The remaining electron pairs, there's no issue. Right? At the beginning we calculate that. But always what should be constant? This electron pairs. The number of electron pairs should be constant. The electron pairs means the bond pairs and lone pairs. Right? The electron pairs means the bond pairs and lone pairs should be 12. Is it there? Bond pairs, lone pairs තමයි 12 වෙන්නේ. Is it there? So then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Clear? That's the point. Remaining electron pair should not be a constant value. At the beginning, we calculate it because we are starting with that. But at the end, in order to confirm the structure, you can't calculate remaining electron pairs. Calculate the total electron pairs as I have calculated. So this is the most stable structure. I can show you the marking scheme right now. This is the original marking scheme of 13 annual paper. So you can see the answer here. Right? And zoom out the screen and check your marks. 10 marks. So can we put the negative charge on oxygen that lies in the corner with a bond pair? Yeah, right. I mean, if you want, you can just change this negative charge to this oxygen and take the double bond to this. Right? It's also okay. Can you make a double bond? Make a negative charge when right? It's just symmetrical. Right? It's okay. No issue. Give the marks. The oxygen negative when so you can see the number of marks we are allocating for that. 10 marks allocated. Definitely you have to mark the lone pairs and charges. Lone pairs charges නැත්නම් මේ marks නෑ, right? You have to allocate the lone pairs and charges. It is better to circle the charge, right? It's better to circle the charge. I mean, this negative charge you can circle like this, right? Positive charge in this circle like this. Yeah. Right, okay. So then what we have to do, we have to start drawing resonance structures. Okay. So can you check my answer? I haven't sent it to WhatsApp. Yes, sure. Send it. I'll check it, right? Please give me a time. I'll check it and I'll send you a comment. You can send answers to WhatsApp, right? Sunday දවස්වල බලන්න මම answers check කරලා එවන්නම්. ප්‍රශ්නයක් නැහැ. weekday mornings තුනක් sure එකක් නැහැ. ගොඩාක් busy වුණත් විතර මම බලන්නේ නැත්තේ නැත්නම් මට චුට්ටක් remembering message එකක් කියන්නේ ගන්න මම එව්වා සර් මොටිවේට් කියලා ඒක පොඩ්ඩක් කියන්නේ follow up message එකක් definitely I'll check, right? Okay. So we have to draw resonance structures. When we draw resonance structures, just forget about this. Lone pairs, charges, just forget about it, right? Then what you have to do, you have to exchange the location of pi bond, right? You have to exchange the location of pi bond. What are the possibilities? How many resonance structures, how many different versions we can take if we exchange this pi bond? If we exchange the location of this pi bond, how many different versions can be taken? Can you predict it? So then here you can keep the pi bond, that's one structure. How many different versions? Is it 2, 3, or 4? So when you exchange the pi bond, what is the rule? You can exchange the pi bond without exceeding the octet. You can have 6 electrons, you can have 2 electrons, that's okay. But you can't exceed 8 electrons when you put the pi bond away. Pi bond එක මාරු කරනකොට ඒ pi bond එක අලුතින් තියෙන place එකේ තියෙන the location that you are going to add the pi bond newly, you can't exceed the octet after putting that pi bond. 8 එක exceed කරන්න බෑ කියලා තමයි මම කිව්වේ, right? That means after putting the pi bond, can we have 6 electrons? Yes, possible, because we can make the 8 using lone pairs. Now we put lone pairs. We put lone pairs and we will make it stable, right? But I'm telling, from the bonds you can't exceed the octet. From the bonds you can't exceed the octet, right? Okay. So here there's one option. You can take this one to here. That's the second option. You can take this one to here. That's the third option, right? Having pi bond at this corner, pi bond at here, and pi bond at here. Can we take the pi bond to NH bond? No. Always hydrogen makes only single bonds. Hydrogen makes only single bonds. You can't put any double bonds to hydrogen, because hydrogen is in the first period. Maximum number of electrons around hydrogen is 2, right? So already you have 2 electrons there as total electrons. So then how many different structures available? Only 3. So first what we do, if we have 3 structures, first what we do when we draw resonance structures? Drawing one structure and putting lone pairs and marking the charges? No. If we have 3 structures, we have counted that you can draw 3 structures, you have to draw your skeleton 3 times, right? You have to draw your skeleton 3 times, like this, right? You have to draw your skeleton 3 times. This is one, right? The second one, and here the third one. Here we have to draw our skeleton 3 times like this. Then what you do? Just put that pi bond away, right? Then put the pi bond here and there. So in one case, you have the pi bond at this location, there. And then where you can put the pi bond? So we can keep the pi bond here. That means the most stable structure is the best Lewis structure. The most stable structure is the first resonance structure. If they are telling excluding the first structure, you can't draw that. If they are telling excluding the first structure, you can't draw in any. They have not given like that. The most stable of the structure you have to draw at the beginning, right? As the first resonance structure. There the pi bond, and here the pi bond, and here the pi bond. Likewise, you can take the pi bond, so then it will not exceed the octet. Then what we do? We have to complete the structure, right? So when we complete the structure, we have to put lone pairs as we get octet. As we get octet, we have to put lone pairs, right? So here 2, 4, 6, 8. 2, 4, 6, 8. Right? 2, 4, 6, 8. Here, right. Here 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8. Right? And here 2, 4, 6, 8. 2, 4, 6, 8. Right? So likewise, 2, 4, 6, 8. We can have octet around each and every species. Then you have to mark charge. This mark the charge. This oxygen negatively charged. Right? This nitrogen positively charged. This nitrogen positively charged. This oxygen negatively charged. Clear? So this nitrogen positively charged. This nitrogen positively charged. This is negative and this is negative. Like this. So you can understand the situation. So then that's resonance arrow you have to apply between the structures, right? Because this structure is moving to this and this structure is moving to this. Because resonance structures are the structures available for one single molecule. They can be different types, different modes of one single structure, resonance structures, right? So, can you tell these structures stable or unstable and the reasons? You have to comment on the reasons. Is it stable or unstable? Stable or unstable? Definitely, this was the most stable structure. So how you say unstable, right? So then you have to comment on stable, and then you have to write 2 reasons on that. The stable when the reasons they are clear. Dala, can you tell me the first reason? First reason, what is the first reason? So you can say clearly, reasons දෙකක් ලියන්න පුළුවන්. මොකද්ද? Low charge distribution. Oh, කමක් නැහැ. Charge distribution low. Accepted. Tamanad. Reasons එනම් 3 ලියන්න පුළුවන්. Electronegative oxygen gets negatively charged, while positive nitrogen gets positively charged. You know, electronegativity of oxygen is higher. Electronegativity of nitrogen is lower. So you can mention electronegative oxygen is getting negatively charged. So it's a sign of stability, right? It's a sign of stability. Electronegative oxygen gets negatively charged. It's a kind of stabilizing. Furthermore, you can comment when you consider adjacent atoms. When you consider adjacent species, if you have different charges, it's a sign of stability. Adjacent species having different charges, it's a sign of stability. Is it there? When adjacent species are having different charges, it's a sign of stabilization, positive and negative. That's what you have to comment, right? Okay. Reasons තුනක් ලියාගන්නද? ඉතින් ඔයගොල්ලෝ second question එක තාම ලියුවේ නැහැ නේ. First එක ලියුවේ. First එක ලියලා ලොබි structure එක complete කරා. First එක ලියලා ලොබි structure complete කරාද? Right? Then after completing that, write the second question. What is the second question? එක ලියාගන්න. Ask questions if you have, right? Draw the resonance structures for this molecule, giving reasons, comment on their stability. Then draw the resonance structures and comment on the stability. Right, okay. So you can check your answers. Get the board here. Choose the number. Electronegative atom get negatively charged. Within the molecular structures too. So please raise your hands if it is clear to you. I'm going to show the marking scheme for this. Right, okay, good. So keep remember you're attending an online class. So then if you have questions, you should ask at the same time. Then just type the question. I'm not reading your name when you're asking question. Then just tell the question. So then I can give the comment on that. Can be a good question or a not related question, anything. Okay. I'm going to discuss. I'm going to get that answer issue here, and I'm going to explain my view on that. Right. So then you can ask anything. So then try to think which question I'm going to ask from this. Always in science classes, you should think more deeply. And then you have to ask from your mind, what is the question that I'm going to ask from sir in the next minute? Always, when you're considering one single class, try to ask at least 3 questions from the sir, from the lesson. And then make sure that you're asking very good questions, reliable questions. It's okay with any question now, but try to ask very good questions. Then this question asking ability will allow you to get more things in your life, right? Especially when you are in a discussion, you can ask from the person who is explaining to you about the views, about the points, right? And then you can defend to each and every point. Right? So then try to ask questions. What will happen in this case? Okay. So can we get like this? Then if you are asking questions, that is you are thinking, right? Okay. So then this is the marking scheme. You can check your answers, right? Can you see? Is it clear? Right? You have pen on it. Stable. Opposite charges on adjacent atoms. Negative charge and more electronegative atom. Just see. Okay. Can zoom out if you want. You can see the resonance arrow also. The first 2 answers that in marking scheme. Right, okay. This was the third structure. Unstable to positive charges on adjacent atoms, right? Or high charge distribution. Okay. So that's all from there. Do we need to draw the most stable structure in the resonance questions too? Yes. Definitely have to draw if they are not telling. Okay. Someone can excluding the first structure. Including that. Okay. Including that. Okay. So then that one we have done. Then I'm going to discuss this table part also. Table part this one. State the following electron pair geometry shape around the atom, hybridization of atom. Okay, related to which one? Related to the most stable structure. So consider the most stable structure and fill this. Right. Consider the most stable structure. Consider the most stable structure and fill this. Right. Can you consider the most stable structure and fill this soon? Electron pair geometry, shape, hybridization. Electron pair geometry, shape, and hybridization. Okay. Electron pair geometry, shape, and hybridization. Okay. So let's get the most stable structure. This is the most stable structure. Most stable structure. So they're asking about two atoms. How the two atoms they get? Right. First one, they're asking nitrogen attached to hydrogen atoms, nitrogen attached to two oxygen atoms. So they are asking about this nitrogen and this nitrogen. Right. So they're asking electron pair geometry, shape, and hybridization. Right? Hybridization. Okay. Let's get this nitrogen. Number one nitrogen. Number one nitrogen. Electron pair geometry shape. How many bond pairs? How many lone pairs? We have to consider only the sigma bonds. 5 bonds gone sigma bonds with only the sigma bonds. So then when you consider sigma bonds and lone pairs, right, you can see 3 sigma bonds and 1 lone pair. 3 sigma bonds and 1 lone pair. Right? 3 1. So then 3 sigma bonds and 1 lone pair shapes table එක මතක් කරගන්න. 3 1 කියන්නේ shape එක මොකද්ද? pyramid. එතකොට shape එකට එන්න ඕනේ pyramid. මම මේ මට ඕන විදිහට table එක හැදුවා. shape එකට ඕන විදිහට ඒගොල්ලෝ ගන්න pyramid. trigonal pyramid කිව්වත් හරිද? හරි. දෙකම එකයි. And how to get electron pair geometry? 3 1 so add 3 plus 1. 3 plus 1. 3 plus 1 can 4. Then see it from the top of the period table. The period table, shape table. 2 0, 3 0, 4 0, 5 0. Then 3 plus 1 is 4. So then check 4 0. Check 4 0. So 4 0 is tetrahedron. Right? Tetrahedron. 4 0 is tetrahedron. Okay, so then how to get hybridization? So the hybridization means sp n minus 1. Hybridization is sp n minus 1. So what is n? Sigma bonds plus lone pairs. Right? Sigma bonds plus lone pairs subtract 1. Isn't it? Sigma bonds plus lone pairs subtract 1. And remember this equation I have given in the first lesson. This is how to find the hybridization. So what is the hybridization around this nitrogen? Count the sigma bonds plus lone pairs. Subtract 1. Take it as the index. Then that is hybridization. We have 3 hybridizations. sp1, sp2, sp3. Which one is this? Very simple. Sigma bonds plus lone pairs subtracting 1. So when we take NH, can we take the bond between N and N? So NH එක ගත්තම N වල bond එක ගන්න පුළුවන් නහන පුළුවන්. NH එක නෙවෙයි around nitrogen we have to take everything, right? So when you consider the central atom as nitrogen, you have to take all the bonds around nitrogen. Nitrogen වටේට තියෙන bonds ඔක්කොම ගන්න. This and this. 3 bond plus 1 lone pair. We can make together. Right. So I'm asking the hybridization of this nitrogen. What is hybridization? What is hybridization? Sigma bonds plus lone pairs subtract 1. Very good. I'm going to count. 1, 2, 3. Sigma bonds 3. Ion pack 4. Subtract 1, sp3. And hybridization එක sp3. හරි ලේසි මේවා හොයන එක. මේ ස්ට්‍රක්චර්ස් හඳුනනකොට ගොඩක් ලේසි. Right. Okay, what about the other nitrogen? When we positive align nitrogen වලට මෙතන fill කරන්න බෑ. Right. I mean for the positive charge nitrogen, try to fill this stuff. Electron pair geometry, shape and hybridization. The electron pair geometry, shape and hybridization. Right, okay. හරි මට answers එවලා තියෙනවා. ඔව්. හරි. මෙහෙම නෑනේ. කවුද මේ? This nitrogen. What is electron pair geometry? කලින් shape එක ගන්නකො. Shape එක ගන්නේ කොහොමද? Bond pairs, lone pairs. Then do we count 5 bonds? No. We don't count 5 bonds. Just count only the sigma bonds and lone pairs. See whether how many sigma bonds around the atom you are considering. Consider කරන atom එක වටේට තියෙන sigma bonds විතරයි බලන්න. 1, 2, 3. So then 3 sigma bonds means 3 bonds. No lone pairs. If there are no lone pairs, electron pair geometry and shape is same. If there are no lone pairs, electron pair geometry and shape is same. Then 3, 0 means trigonal plane. Trigonal plane. Lone pairs නැති නිසා මේ දෙක same. Okay? Electron pair geometry and shape, trigonal plane, trigonal plane. Both are trigonal plane. And finally, hybridization. What is the hybridization around this nitrogen? Hybridization means sp(n minus 1). So then get the rest of pairs. Sigma bonds plus lone pairs. 1, 2, 3. එකක් අඩු කරන්න. 1, 2, 3 එකක් අඩු කරන්න sp2. හරිනේ? So please raise your hands if it is clear. That is 2013 question. අපි ඔයගේ අද 14 කරනවා. 17, 18, 19, 20, 21 ඔක්කොම. Right, okay, let's go to the next question. So you can check the marks from the marking scheme. Make a part එක කරන්න බෑ fold the non-fold කියන එක. අනිත් ටික හරි නේද? හරි. You can see how they are giving marks in the marking scheme. Right. So I'm moving to the next question. This is 2014 question, right? I will put this one. This is 2014 level. So then what you have to do, you have to write the name of the molecule and you have to count the electron pairs, right? Please count the remaining electron pairs. Then you can draw the skeleton here, draw the skeleton and put the remaining electron pairs to the skeleton and get the most acceptable result. Okay, get 2 minutes. 2014 level question. So get your questions book and calculate the remaining electron pairs, right? Remaining electron. Okay. How you check the molecule polar or non-polar? In order to check a molecule polar or non-polar, definitely you should know dipole moment. Right? I'll do a part called dipole moment in the last episode of this shapes lesson. From that, you can find whether a molecule is polar or non-polar. It's very simple thing, but it's called dipole moment. You have to you have to draw the shape, and you have to mark the electron flow, and you have to see whether there's any resultant vector. Right? That's a lesson, right? So no need to mix up with that. So we'll keep it. The molecule polar or non-polar. Then after doing dipole moment, we can do second interactions. Right? Keep it. So then count the electrons. How many electron pairs remaining here? How many electron pairs remaining? Send the remaining electron pairs. Draw the structures also. N, C, N, C, N, H2, and N, H2. Right. Draw the most acceptable Lewis structure. Okay, අපිට electron pairs ඉතුරු වෙන ගාන වෙලා තියෙනවා. So carbon 4 times අතරව දෙකක් තියෙනවා 8යි 8. Then hydrogen 4. Hydrogen 5 times 4 20. Then the total electrons 20 plus 8 28, 28 plus 4 28 plus 4 32. Then we have 32 electrons, so then we can take electron pairs. So as electron pairs, we will take 16. As electron pairs, we will take 16. So from these 16 electron pairs, you can subtract the bond pairs, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Just subtract 9. Then you get the remaining electron pairs, right? So that is 7. So have you got the 7 remaining electron pairs with you? Right? So there. Then just put 7 lone pairs around each and every atom, right? I mean 1, 2, 3, 4, 5, 6, 7, likewise randomly distribute it. Is it clear? Okay, please do up to this. I'm going to make a video again live. We're going to go right. Don't just put 5 bonds. Here 5 bonds put lone pairs first. Then don't mark any charges. Just put lone pairs and keep it like this. But when you put lone pairs, don't use the pen. Use the pencil. Because we have to erase lone pairs and make bonds when we make this table. You know, higher the number of double bonds and triple bonds, we can make a structure simple. Right? Structure more stable. Okay, so let's start. What do you have to do? You have to put, you have to complete the octet, right? Start from one direction. So complete the octet and then charge. Complete octet and charge. See whether. See here. 2, 4, 6, 8. Octet, is it available or not? Well, structure right? Octet, is it available or not? Octet is 2, 4, 6, 8. Mage again clear. So, structure octet. If you don't have the octet, it is a lone pair and take the octet. Have 8 electrons, right? Could be bonds or it could be lone pairs, have 8 electrons, right? So after having the octet, what do? You should check the charge. Now, what is the charge? What is the charge of my nitrogen here? Can you give any answers? 1, 2, 3, 4, 5, 6, 7. So nitrogen is in group 5. My charge is -2. Please do not mark -2. Then it's incorrect. Okay, mark right? Because we have to minimize the charge. -2 na 0 karanga. Right? So we have to minimize the charge. I mean, we have to make the charge as 0. And -2 means excess amount of electrons. -2 means we have excess amount of electrons. So then what we have to do, we have to make it 0. So in order to make it 0, what is the option? Octet charge minimize, right? So this option is erasing the lone pair and making the bond, right? So you can erase the lone pair and put a bond. There, 2, 4, 6, 8. Erase the lone pair and put a bond. Octet is there. Check the charge. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. The charge is minus. Right? Now the charge of this nitrogen is minus. Now again we want to minimize it. See here, I'm erasing the next lone pair and putting the bond. So now I have done, right? I've done what I required because I wanted to make the nitrogen as 0 and I want to make nitrogen completing its octet. Both are perfect, or both are done at this. We have completed at this time, right? Okay, let's move to carbon. So when you consider carbon, what is the first problem, right? What is the first problem here? Carbon. Check the octet, right? So when you check the octet, 2, 4, 6, 8, 10, 12, ambo. And the octet, right? First of all, remove the excess and make 8. Make 8, right? Remove can erase can put it to another atom. That's the lone pair. Mehe to le anne pa. They better clean karenge inne, right? And lone pair to here, right? And this lone pair also you can put it to here. Okay, lone pairs hydrogen not dala dakne. Hydrogen lone pairs can. Okay, now you can see we have made octet, and the charge is also 0. Because carbon is in group 4, as we have 4 individual electrons, the charge is 0. Right? Okay. Then what about this nitrogen? Again, our option, our mission is to complete the octet and have charge, have 0 charge. So then here 2, 4, 6 electron octet is available. What about the charge? Can we minimize the charge here? Yes, the charge is -1. 1, 2, 3, 4, 5, 6. There are 6 individual electrons around this nitrogen. So we have a minus charge. Can we minimize the charge or not? Can we make the charge as 0? Is it possible? Right? Yes, we can. How? Erase the lone pair. You want to reduce, then put a bond. Now check the octet. 2, 4, 6, 8. Right? Now check the octet. That's 2, 4, 6, 8. Right? 2, 4, 6, 8. So you have 8 electrons there. Right? Have 8 electrons there. So then we can clearly say charge is 0. Sorry, 8 electrons here. Octet completed. Charge is 0 because we have 5 individual electrons. 1, 2, 3, 4, 5. Now all the 3 atoms we have completed. Now we are coming towards carbon. Right? We're coming towards carbon. Right? Okay. Now there's a problem. What's the first problem to me? Right? At this moment, you can see I have exceeded the octet around carbon. 2, 4, 6, 8, 10. What's my point? Right? What's the solution? Yes. So I'm going to remove this lone pair. And I will be putting it to a certain point. Where's that location? Right? Very simple. can put that to here. Simple, right? Now we can understand about carbon octet is there, charge is here. මේක නිකන් අර puzzle එකක් හදනවා. يعني පොඩි කාලේ තියෙන එක pictures තියෙනවා. පොඩක් එහෙම මෙහෙට කරාම picture එක අවුල් වෙනවා. මම දන්නේ නැහැ ඔයගොල්ලෝ සෙල්ලම් කරාද කියලා online ඒවා තිබ්බද දන්නේ නැහැ. අපේ කාලේ තියෙනවා. ඊට පස්සේ puzzle එක එහෙට මෙහෙට ගෙනිච්චාම අර picture එක විදිහට set වෙනවා. අර online එකේ මෙහෙම කරලා ඒක ඒ diagram එක හදාගන්න. හරියට set වෙනවා. අන්තිම හරියට ටික ටික ගාලා set කරන්න පුළුවන්. right? maybe 2 4 6 8 octet උත් හරි charge උත්. ඒවා automatically set වෙනවා. 2 4 6 8 2 4 6 8. So in this molecule you can see we have created the molecule with zero charge, completing the octet, right? That's the most stable structure we can have. I mean, if we are having charges in this, we can't say that's the most stable structure because there's a structure with zero charge. There's a structure with zero charge. So as there's a structure with zero charge, we can say a structure that is having a charge as the most stable structure. Clear? Right. So that's the most stable structure. And after that, do you think how many resonance structures I will get? Right? How many resonance structures? Actually, for this molecule, you can draw many more resonance structures than you expect. Right? Many more resonance structures than you expect. They're asking, I think, like 3 resonance structures. They're asking like 3 resonance structures. But we can draw more resonance structures for this. Right? Let's check. Like this. So what do you have to do? Right. So then just forget the non pass. Let's forget the non pass. And take how many pi bonds you have. See how many pi bonds we have. We have 3 pi bonds in our structure. Right? We have 3 pi bonds in our structure. This. So you have to exchange the pi bond as you are not exceeding the octet around each and every atom. So what is my point? First of all, hold the 2 pi bonds. When you make a hold these 2 pi bonds and mark it. Right? And then try to exchange this pi bond. Make pi bond how many possible cases? How many different combinations? When this bond is there, that's one structure. Where you can put this bond. This bond is here, that's one structure. You can put this bond too. Right? So you can erase this bond and you can place it to you can place it here. Right? You're not exceeding the octet. Can you see? From the bonds, you are not exceeding the octet. Right? Again, what you can do, you can place that bond to here. You can place that bond to here. Right? So here we had one structure, here we had another structure, and when the bond is here, we will have the third structure. Can you understand? So when the bond is here, we will have the third structure. That's most important. Right. So we have 3 structures from there. Excluding the first structure, we just have 2. Including the first structure, we have 3. Right, okay. Now what else we can do? What else we can do? Right? Again, I'm moving to the original structure here. This was the first structure. Now I'm going to change 1 pi bond from here. I'm going to take 1 pi bond from here. And I'm going to put it to different locations where I can put it. Definitely, I can take this pi bond and put it here. without exceeding the octet, isn't it? See this one? When I'm taking one pi bond is remaining, and I can put it here, right? And that bond is there. There. Like this, I can take. That's the point. Like this, I can take. And then what we can do, at the same time, we can take two pi bonds together. I mean, this pi bond also you can take it to here, but there's an issue. If this bond is there, it will exceed the octet. One can එකම වෙලාවේ pi bonds දෙකම මාරු කරන්න. You can change the two pi bonds at once, but in that case, this will be an issue. To erase this bond, I put it to this side. Can you understand what we are doing? We put this pi bond to here. Otherwise, the octet will exceed around this nitrogen. And then we can take the double bond, two pi bonds together to here, right? I mean, this was the structure that I am talking about. Can you understand? Likewise, we have to draw different combinations, taking from the more stable structure by exchanging the location of the pi bond. By changing the location of the pi bond. That's how we derive the resonance structures. Isn't it? There's a methodology. There's a clear methodology you have to practice. You have to experience, right? So can we get more structures? I think we can get one structure. Can you tell what is the structure here I can take furthermore? That's a deviation of this. That's a deviation of this. Can you just predict it? I mean, even the structure you can modify. You can remix and get another structure. So what you have to keep remember, you can't exceed the octet from the bonds. Bonds filling octet එක exceed කරන්න බෑ. Right? You can't exceed the octet from the bonds. Okay, can you predict the next one? Double bond එක carbon hydrogen වලට ලියන්න කියලා. Yes, that's what, right? I mean, there you can see the triple bond, right? You can keep the triple bond there, and you can take this CN double bond to this, right? Like this. So we can take 1, 2, 3, 4, 5, including this 6, right? Then draw 6 structures. So after drawing the available options or combinations, what we do, we have to put lone pairs until we get the octet, right? Until we get the octet, we have to put lone pairs like this, right? And put resonance arrows in between that. So see how we are putting lone pairs. 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8. Right? And then here there's a positive charge, right? Then 1, 2, 3, 4, 5, 6. This is negatively charged. Right? 2, 4, 6, 8. Right? 2, 4, 6, 8. So 1, 2, 3, 4, 5, 6. This is negative. Then 2, 4, 6, 8. 2, 4, 6, 8. So this is plus, right? So always put 8 electrons. I'm going to count 2, 4, 6, 8 here. Electrons left and non-pass only. Then mark the charge. When you mark the charge, see the number of individual electrons, whether it is equal to group number. If it's equal to group number, the charge is 0. If it is exceeding the group number, it will get negative charges. If it is less than the group number, it will get positive charges, right? So then here 2, 4, 6, 8. This is minus 2, right? 2, 4, 6, 8 plus 2, 4, 6, 8, right? Like this. Plus 2, 4, 6, 8 minus, right? Minus 2. 2, 4, 6, 8 plus 1, 2, 3, 4 plus, right? And then this. So please raise your hand if it is clear. Mark the structures and try to complete the structures soon. I can add a photo of your WhatsApp group, right? It's important question. Well, Rashidini. So by a charge cancel out can't be minimize the charge. So by a charge as a cancel. By a charge as a cancel out can't be minimize the charge. The question is not clear, right? So I try to send it again. Then try to make it more clear. So then always the resultant charge should be cancelled, right? Because the entire molecule is not having any charge. So then when you consider the charge distribution, there can be charges, but the resultant charge should be 0. Right? Charges are addition to 0 when the mode in this molecule. Right? So please raise your hands if you have completed all the 6 structures. Plus and minus charges, same molecule. Or plus minus එකම molecule එකේ එන්න පුළුවන් ප්‍රශ්නයක් නැහැ. Then the molecule is unstable. The molecule එක ගත්තම හොඳටම unstable. High charge distribution. Right? High charge distribution. So please mark the charge. Please mark the lone pairs. Make sure you have put resonance arrow. And then write stable or unstable under each and every structure. හැම එකටම stable ද unstable ද ලියන්න. If possible, write one reason for that. Stable නම් stable වෙන්න reason එක. දැන් මේක more stable, මේකට අපිට unstable කියන්න බෑ. We can say it is less stable. Right? So fourth structure එක right corner එකේ it should have positive charge නේද? මෙයා නේද? එතන මොකක් හරි ප්‍රශ්නයක් තියෙනව නේද? I'll check that. Wait. I'm checking it. Next structure එකේ charge එක 0 වෙන්නේ නැහැ. ඒක බලන්න ඕනේ පොරක්. Total electron pairs 16. See whether I have drawn total 16 electron pairs. Right? 16 electron pairs. So then count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Check ready. Lone pair ready වෙලා තියෙනවා. Right? One lone pair is excess. because the total electron pairs is 16, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Right. So in this lone pair you have to remove. That will exceed the octet. Then I can put plus. Okay, that's correct. And the end of the lone pair must be removed. Right. Overall charge is 0 when so in the exam they had asked exam the structures tonight, but we can draw many more structures. There are MCQ questions. They are asking how many resonance structures we can draw. In 2015 level exam, there was an MCQ. We had 9 resonance structures. 9 resonance structures. 9 resonance structures. MCQ. So by next week you will be having your school results, and then you have to go to school, and then I think they will send Google Forms to register you to your A levels. Even you are attending to your own school, you have to register. You have to pay facilitation fees, right? And then you have to get your school kits, and then new books, a bag, okay, and shoes, and right? Again you have to get ready for the mission after a long time, I think, right? So, however, okay, right. So in school, you have these 3 subjects, and you have GIT, you have English, and then apart from that, sometimes there's a project subject, right? So then definitely there are 2 more subjects, English and GIT. And then apart from that, there are some library periods also in some schools. Okay. There's a project also you have to do. That's a group project, right? 1.5 years. So again, GIT, there's exam. There's exam, right? So you have to learn GIT, right? General Information of Technology. I think there's a book also, right? That's the point. And my advice is, when you are learning science in A-level schools, especially, do not try to do extracurricular activities. Sometimes you have to do getting the prefectship, head prefect, deputy head prefect, right? Team leader of soccer team or football team or cricket team. That's a huge responsibility. So if you are getting that type of responsibility with these lessons, it's always be difficult to bear up, right? It's difficult to manage this stuff. That's my experience. You can just get some short positions like school associations, simple associations, science society. Those are simple cases. But if you are getting the head prefect of your school, or if you are getting the leader, or you're getting the captaincy of your cricket team, or that kind of a thing, that will be a hard challenge, right? Then please do not accept those cases, especially in the foundation year, because you are doing A-level maths, you are doing A-level science. It's difficult to bear up, as we have experienced from our students, right? Because your main target is to attend government universities. You will be getting a scholarship, right? So then in universities, all those activities are available. You think those activities are available in schools? No, not in schools, right? Schools, they are available, but it is totally freely available in universities. Then university level, you can practice it, and you can move to inter-university level, and international university games also you can take part from any section that you are having extracurricular talents, extra talents, right? So your main intention is to do studies well if you are doing A-level maths and science, right? I'm going to show the marking scheme of this part. So let's go to 2014 marking. That's in Sinhala, it's okay, right? You can see the answer. This is the most acceptable of structure. You can see 8 marks we have given for this part. Okay. Here we have expanded the structure NH2. They have minimized the structure, right? So you can see they have marked the lone pairs. And then the other resonance structures. So please check your answers whether you have drawn all the resonance structures with the corresponding charges. Method 1, 2, 3, 4, 5, 6, 7. Here method the most stable 17. But check if you have not drawn any structure, you can draw that structure also. So always you can count the bond pairs, total number of electron pairs plus lone pairs around each and every atom. 4, 6, 8, 10. මේව නම් වැරදි. මේක නම් වෙන්නම් බෑ. ඔක්ටට් එක exceed වෙලානේ. ගොඩකින් මේ answers වැරදි වගේ. Just wait. Right. I think I'm going to but I can give one letter getting English medium marks. So it's 2016 one, right? So 17. Right, okay. So I can show this answer again. I get English word. Okay, this is the answer. So these are the resonance structures. 1, 2, 3, 4, 5, 6. Okay, these are the resonance structures. Is there any textbook for physical science? No. For combined maths or for biology. So for biology, you have those resource books. Physics also resource books are there. Chemistry also resource books are there. Combined maths also resource books there. Right. But there are some books in educational department targeted for different lessons. Right. Okay, check your answers. I think you have completed, right? Okay, let's go to the next one. Okay, in the plan. Can you fill the table now? Okay. So get the most stable structure. State the following, right? So there are the most stable structure and then method මුලින්ම මේක හරි. අනේ most stable structure දිහා බලලා මේ table එක fill කරා. Electron pair geometry, shape and hybridization. Right. Electron pair geometry, shape and hybridization. So focus on the most stable structure and fill that. Right, okay. So shall we check the answers? You can check the answers for that part. It's available. So you can see C2, right? What is C2? C2 is this one, second carbon, right? Second carbon, electron pair geometry, shape and hybridization, right? This one. So what is shape? 2 bonds, 0 lone pairs. 2 bonds, 0 lone pairs, linear. Electron pair geometry is also linear. What is the hybridization of this carbon? Hybridization, very simple. sp(n minus 1, right? What is n? Sigma bonds plus lone pairs. Don't consider pi bonds. Just have 2 sigma bonds. The pi bonds can lepa. Right? Pi bonds and shape electron pair geometry hybridization right? You just have 2 sigma bonds, right? No lone pairs. So 2 minus 1 is 1. So there is sp hybridization, right? We make carbon 10 sp hybridization. That is C2. So please check your answer. Whether that part is okay, right? This C2. So that's the linear sp. So let's take about N3, right? So what is N3 here? This one. N3, electron pair geometry, shape and hybridization. Electron pair geometry, shape and hybridization, right? Focus on N3. So N3 කියන්නේ එතකොට මෙතන මේ අනිත් nitrogen එකනේ මේ nitrogen එක. So electron pair geometry, shape and hybridization. This one. So when you consider 2 bonds, 2 lone pairs, right? 2 bonds, 2 lone pairs, that is angular. 2 bonds, 2 lone pairs, that's angular, right? And then when you consider electron pair geometry, add it together, right? 1, 2, 3, 4. 1, 2, 3, 4. So then 4, 0. 4, 0, that is tetrahedron, right? That is tetrahedron. That's electron pair geometry. 2 bonds, 2 lone pairs, angular. The electron pair geometry is tetrahedron, right? Furthermore, what is hybridization? 1, 2, 3, 4, right? Subtract 1, that is sp3 hybridization, right? 1, 2, 3, 4, subtract 1, that is sp3 hybridization. Can you understand? Right, okay. මෙතන sp2 නෙවෙයි sp3 වෙන්න ඕනේ. මේක sp2 වෙන්න බෑ, right? n3 නේ තියෙන්නේ. n3 පොඩ්ඩක් එන්න check කරන්න sp2 කියලා තමයි තියෙන්නේ. 1, 2, 3. Oh, this is sp2 hybridization. That's okay. The thing about this nitrogen, මම ඇඳලා තියෙන වෙන resonance structure එක. In my board, it's a different resonance structure, right? This was there. That is 1, 2, 3. sp2 hybridization. 2 bonds, 1 lone pair, that's angular, right? 2 bonds, 1 lone pair, the shape is angular, electron pair geometry is trigonal plane. 2 bonds, 1 lone pair, shape is angular, electron pair geometry 2 plus 1, 3, trigonal plane. Hybridization 1, 2, 3, subtract 1. Speed. This responsibility is there. Okay. Check the other answers also. අනිත් answers check කරගන්න. Right, okay. C4, N5, N6. Check your answers. That okay. So you can see the lawn pairs. Shape, right? So how to draw this shape? I explain right? So in the next question, 2014 annual question, they're asking sketch the shape of this one, right? So actually, how to sketch the shape, right? So this is how to sketch the shape. That's a simple part, right? This way. So when you sketch the shape, now this is not the shape now. This is the most stable structure. So when you sketch the shape of this, you have to focus on the most stable structure and see the sketch that I'm going to take. Start with a double bond, right? It's better to start with a double bond if it's possible. So where are the double bonds available? Here you have the double bonds, right? You can start with the double bond. And then what you can do, after drawing the double bond, you can consider the electron pair geometry, right? And consider the electron pair geometry of that, right? Now here they have carbon-carbon double bond. So start from this N double bond C. N double bond C. So what is the electron pair geometry of this nitrogen? Around the nitrogen, the electron pair geometry is trigonal plane, right? 1, 2, 3. Around the nitrogen, the electron pair geometry is trigonal plane. Just mark it like this. You can understand? Around the nitrogen, the electron pair geometry is trigonal plane. So then you can put this non-pair here, right? And then you know this carbon and this nitrogen, right? This is a linear one, right? sp hybridization is linear. So then put it linearly. C triple bond N. C triple bond N, and that's a non, right? And then this to this carbon also you should have two bonds, trigonal plane, right? So this and then this. Then we can connect this nitrogen. That nitrogen 1, 2, 3, 4. So drawing NH2 1, 2, 3, 4 means tetrahedral. We don't focus on shape. We have to focus on electron pair geometry. So the tetrahedral means we have to have three repulsive units like this. So the one is a lone pair, right? One is a lone pair, other two hydrogens, right? And then here also 1, 2, 3, right? So we have to have two hydrogens and one lone pair like this. That's it. So that's how we have to sketch. And do we have to mark the bond angle? Yes, of course, right? So I have clearly stated if it is tetrahedral, the bond angle is 109. So in the tetrahedral version, if you get one bond as a lone pair, the bond have lone pair the bond angle between the others will become 107. In the tetrahedral version, if you get two bonds as lone pair, if you get two bonds as lone pairs, the bond angle between the others will become 104. And then if you get trigonal planar format like this is 120. Right? In the trigonal planar format also, if you get one bond as a lone pair, this one will become 170. Right? 117. That's very important. Other than that, you will have 180 degrees linear one, right? So you have to mark them. The 80 marker, right? So this is 180. This is 120. Right? This one also 120. Right? This also 120. Yeah. 120. Okay. Then 20 170. Because two bonds, one bond. This is 120. These are correct. Right? Here 3 1. 3 1 can make it 107. Right? Can mark the bond angles. 3 1. 107. So please raise your hand if it is clear. Start from the double bond. Listen again, double bond again start කරන්න. මේ double bond එක මෙතන ඉඳලා start කරන්න. එයාගේ trigonal planar format එක දාගන්න. Right? Sketch the shape. Right? This is 14 questions still we are doing. Right, okay. Raise your hands if you have completed. Good. So you can check the marking scheme answer also. I can share it, right? This was the marking scheme answer, single medium answer, right? You can see there are some bond angles. For this one, I stated that's 117. There are 120, so you can see 4 bond angles marked, right? NH2 they haven't marked in the tetrahedral format, but that's the exact way, right? Okay, so we are moving to the next question discussion. So here we discussed 2014 question. Now the next discussion is on 2017 question, right? So 17 question. So there are 2 questions we have to discuss. Okay, so this is 2017. The question first one is draw the most acceptable level structure for this one, right? I want to make a pen at very some hunter moment in the end. Right? ClO2 F2 plus, right? ClO2 F2 plus. Draw that. They haven't given a central atom, we have to focus on that. Then sulfine, they have given a structure. They are asking draw another 2 Lewis structures. Our Lewis structures are in the right? So make a pen at the HCH double bond S O, right? Okay, starting it. Could you please show the sketch and the marking scheme again? Marking scheme එක පෙන්නන්න කිව්වනේ. Right. ඉතින් screenshot එකක් ගන්න. යාර මේ launch pad එක මම අර මෙහෙම පිළිගන්න තේරෙන්නේ කියලා මේ පැත්තට යන්න. It's okay. හරිනේ? Right. This is the English medium one. Okay. So then this is 2017 A-level question. So please start doing 2017 A-level question now. And okay, we are going to check the answers. Cl(O2) F2+. So what is the central atom? Right? Cl(O2) F2+. So definitely, first of all, count the electron pairs and start. Right? Electron pairs count karan. So chlorine 7, oxygen 6 times to 12, chlorine 7 times to 14, then 14 plus 7, okay. 14 plus 12, 26. Right? And there's a positive charge. So positive charge means you have to deduct an electron. Then 7 minus 1 is 6, right? Then 20, 32. 32 electron means 16 pairs. So you should have 16 electron pairs in your structure. So which one is the central atom? It is chlorine, electropositive atom, right? Chlorine, so then you have to have 2 oxygens and then 2 chlorines, like this, easily. And then 16 pairs you can mark around this 1, 2, 3. Right? So you have to subtract the 4 bond pairs, 1 pairs and just 12 pairs you have to mark as electron pairs. Right? Electron pairs 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Is it? So then what do? You can erase the lone pairs and make bonds. Lone pairs erase color bonds, full, right? So you can erase the lone pairs and put bonds. Erase the lone pairs and put bonds. So then we have to get the bond pairs, right? We have to get the bond pairs. So we have to complete the octet, right? See here how I'm completing the octet. 2, 4, 6, 8 octet is there, but there's a charge. So in order to minimize the charge, erase the lone pair and put the bond. Erase the lone pair and put the bond. Now the charge is 0, octet is there. Charge is 0, octet is there, then check the chlorine. So when there's a positive charge, when there's a positive charge, we give the positive charge to the electropositive atom. What is the electropositive atom? Electronegative atom. That's chlorine. Then we are giving the positive charge to chlorine. Why we are giving the positive charge to chlorine? Because chlorine is in group 7. How many electrons around chlorine now? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. The chlorine in group 7. Around chlorine we have only 6 electrons. Right? Chlorine is in group 7. Around chlorine we have only 6 electrons. So that's why there's a positive charge. Right? That's why there's a positive charge. Right. So Cl(O2) F2+. Cl(O2) F2+. Okay, then what do? You have to draw resonance structures. The resonance structures are in the molecule, right? Take a focus color balance. This was the molecule H, C, H, then S, double bond O, like this, and then like this. So then, how to make resonance structures? You don't want to worry about sulfur. Because sulfur octet prashnayak nahi, you can have more than 80 electrons. So if you are going to draw more structures, what you can do? You can take the pi bond and put it here. Right? Or you can take this pi bond and put it here. So you can take the pi bond and put a lone pair. And then the pi bond again lone pair to that right? So when you get resonance structures, there are 2 options. Right? There are 2 possible options. As you have 2 pi bonds, you can exchange the location of the pi bonds. Right? So draw some skeletons H, C, H, S, O, H, C, H, S, O, H, C, H, S, O, H, C, H, S, and O. Like this. So then take the pi bond to here, right? But around carbon you can't have more than 80 electrons. So then the best thing is, okay, and put this pi bond to here as a lone pair. Lone pair right? So furthermore, and take this pi bond to this side, right? And make sulfur oxygen as a triple bond. You can put a lone pair to the octet, right? Sulfur oxygen. And then you can get this pi bond on this oxygen also, right? And then this single bond will again not follow. And how to complete the structure? Put the octet, right? Put the lone pass until you complete the octet 2, 4, 6, 8, 2, 4, 6, 8. But around sulfur you can't complete the octet, right? Sulfur octet 9. Check about the charge. You have to focus on the charge. Sulfur is in group 6. Around sulfur there should be 6 electrons, right? In 1, 2, 3. So 3. So it's better that you can get one more bond. 1, 2, 3, 4, 5, 6. Right. So we can put single electrons. Better to put another one. 1, 2, 3, 4, 5, 6. Likewise, we can put a double. So then it will make a charge here, right? Then here 1, 2, 3, 4, 5. So that's a negative charge, right? 1, 2, 3, 4, 5, 6. That's 0 charge. Then this oxygen gets positive, right? You can see we have completed the octet around carbon and oxygen, but sulfur we don't want to complete any octet. But we have to mark the charge for everyone, right? So let's move to the resource book. Sorry, the marking scheme answers here. This is 2017 question. Now you can get the answers of 2017 paper here. These are the answers, right? This is the most stable Lewis structure. You get 7 marks for this. So please check if you have taken correct answer. ClO2 F2 plus. ClO2 F2 plus. Most stable Lewis structure. So you can see the resonance structures now. So in all these resonance structures, the total number of electron pairs should be 16, right? You can't exceed that 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Total number of electron pairs should be a constant value. 9 only. Okay, CH2SO. Please focus on that. You can get any of these 4 structures, right? So you can see in some structures they have erased the pi bond and make the pi bond erase kala lone pairs dala. Can you see this one? So then when it is difficult to draw resonance structures, we do this option. This option is possible. 2017 levels. So please check the answers. Okay, next we are moving to 2018 levels. Right, take a screenshot of this. So mark the charges. Right, this is negative and this is positive. Right, this is positive and this is negative. Right. Okay. So next one is 2018 level. We are discussing only the first 2 questions. So then these 2, right? Please complete it. Take 1 minute. Draw the most acceptable level structure. So then count the electron pairs and draw the most acceptable level structure for this. They have given carbon suboxide, right? C3O2. So you have to draw resonance structures. Another 2 Lewis structures for this. And just exchange the pi bond and draw more structures. Okay. Take 2 minutes. Any questions? Shouldn't we mention it is stable, not even though they haven't asked? Because I mention karanne. If they are not asking to comment on the stability, we don't want to comment. If they are asking only, we have to comment. Okay, so start doing 2018. Right, I'm going to discuss SF3N, right? Then for these simple structures, they won't give the skeleton, right? So sulfur is the central atom. They have drawn 3 fluorines and then nitrogen, right? Then you can calculate the remaining electron pairs and then you can put it and get the business, right? Correctly. SF3N, then sulfur 6 electrons, fluorine 7 times 2, 21, nitrogen 5, 21 plus 5 can 26, 32 nil. 32 divided by 2 can 16 pairs, right? 16 pairs selling then 4 pairs, then you get 12 electron pairs. Is it clear? 12 electron pairs. Then 1, 2, 3, 4, 5, 6, 7, 8, 9. 9, 10, 11, 12. 12. Then what do you have to do? You have to erase the lone pairs and put bonds, right? So erase the lone pair and put a bond. Right? Erase the lone pair and put a bond. එහෙම කරන්නේ charge එක 0 කරන්න. Right. Octet එක තිබ්බට වැඩක් නැහැ charge එක 0 නැත්නම්. Then this is the way. Nitrogen के charge is 0, fluorine 0, 0, sulfur 0 නේද? Sulfur is in group 6, right? So 1, 2, 3, 4, 5, 6. Charge is 0. Right. So your mic has switch on, right? Okay. So 1, 2, 3, 4, 5, 6. Is it clear? Okay. So please raise your hand if it is clear. Right, okay. Thank you. When I give me some of the Zoom screen. I think when you take question is my pen. Okay. When nitrogen is at the center. Never mind. Nitrogen electronegativity 3.0. Sulfur electronegativity 2.5. Electronegativity adu atom එක තමයි central එක. Right? The nitrogen central ගත්තොත් වැරදි මේ. Mention that always lowest electronegative atom is the central atom. But you can take hydrogen, right? So in this case, nitrogen and sulfur is sulfur. So by doing more questions, you have to experience this, right? Okay, what about the resonance structures? Carbon suboxide. So when you get the resonance structures part, for that carbon suboxide, what was the molecule? C3O2. C3O2, right? So O, C, 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 O, right? C to 9 O dekha. So then how to complete this? They have given 5 bonds here, 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 and here. So what you have to do? You have to make it stable, right? Make it stable. So as you want to make it stable, what you have to do? You have to exchange the 5 bonds. So how many resonance structures you have taken? Different combinations. Just forget the lone pairs and exchange the location of 5 bonds. You can put 5 bonds here and there and just make different structures, right? What are they? O, C, 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 O. O, C, 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 O. O, C, 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 O. Right? O, C, 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 O. Right? So what you can do, you can take this 5 bond here, right? At once take only one 5 bond. Right? So then just forget the lone pairs and take this 1 5 bond here and take the triple bond, right? And you can take the 2 doubles. Like Mama change kare ekam එක 5 bond එක. ඔයගොල්ලන් තමයි 5 bonds ඔක්කොම change කරන්න හදන එකපාර. එහෙම එපා. Just change 1 5 bond at once. අර ලස්සන structure එකක් ආවනේ. නේද? Alright. Let's get the next structure. What is the next structure? Right. So plan the next structure. So my next structure is, right, taking this 5 bond to here, right, keeping this to there and taking that 5 bond to there. Is it clear? How to plan the structures. So actually 1 triple bond means 2 double bonds. එක triple bond එකක් double bonds දෙකක්. Right. Then here you have 4 double bonds. How many triple bonds are there? 4 double bonds means 2 triple bonds. Right. Why I am telling like that? Because if you get 2 double bonds like this, you can erase the pi bond and make a bond here. And that's a triple bond. Isn't it? That's what I am telling. 2 pi bonds or 2 double bonds means 1 triple bond. Furthermore, you can take this pi bond also here, right? You can take the 2 triple bond version like this. Triple bond දෙකක් වෙන version එකකුත් දැන් යන්න පුළුවන් මේවා. මම ලස්සන structures ටික එනවා. හරි. So then what you do, you can put lone pairs and make it stable. ලස්සන structures ටික අදගත්තා. octet එක නිකන් lone pairs දාලා charge එක mark කරනවා. අන්න resonance structures කොච්චර lazy lesson එකක්ද කියන්නේ. ඔයාලා යාළුවන්ගෙන් අහලා බලන්නකෝ මේක හැටි. ඒගොල්ලෝ මේ questions කරලා තියා මේවා දැකලා තියෙනවා. ඉස්කෝලේ ගියාම බලන්න ඕනේ. past papers පොතක්වත් අරන් නැහැ අඩුම ගන්න. වෙන මොකක්ද? 2 4 6 8. ඔයාගොල්ලෝ past papers පොත අරන් තිබෙන අතර අපි questions tips වල දාලා දෙනවා. Right? 2 4 6 8. So then this is positive. 2 4 6 8. 2 4 6 8. 2 4 6 8. 2 4 6 8. And so this is negative. And you have no charge. Right? Then hurry. So what you think? Hadana din on ekak 2 4 6 8 එක lone gas දැම්මා. Mark the charge. Right? Compare the structures. Raise your hands if you have completed. දැන් මම complete කරා ඇති. දැන් අපි mark scheme එකේ answers බලමු. ඔන්න 18 mark scheme එක share කරන්න හදන්නේ. Right, okay. So this is 2018 marking scheme. Check your answers. That's the 1 2 3 4 5. There are 5 structures for the charges. Okay, so this is the most stable structure. 8 marks for this. Then ලකුණටයි. අනේ. දැන් මේ question එක පුළුවන් නම් ආයි second structure දෙක පුළුවන්. ආයෙත් දැන් first structure දෙක. මේ දෙක තමයි Lewis structures වල අමාරු part එක. මේ දෙක තේරෙනවා නම් මේ table එහෙම නැතිනම් මේ table එක දන්නවනේ Western pairs electron pair geometry shape hybridization. දාම ඔය ටිකම යහන්නේ. ඔතනින් question එක ඉවරයි. මේ ඔක්කොම hybridization. Hybridization එකමයි මේ hybridization එකමයි ලියන්න තියෙන්නේ. පොඩ්ඩක්වත් බය වෙන්න දෙයක් නෑ right? Nothing ලියාගෙන යන්න බෑ. ඊට පස්සේ තියෙන second question මේ first එක ඉවර වෙනවා මෙතනින්. මේ තියෙන second question මේක P block ඉනවගනි. right? Need 6. I think මේකේ talent එකට sorry target එක තියෙන්නේ first 2 questions. මේ දෙක නෙවුවා කියන්නේ ගොඩ තමයි. ඒක ටික ඔක්කොම ලියන්න ඕනේ. A levels වල hydrogen emission spectrum වත් අහන්නේ නැහැ. A levels වල අහන්නේ නැහැ. ඔයගොල්ලන්ගේ term test වල අහයි. මේක අහනවා. 2021 A level එකක් තියෙනවා. right? උදේට මතක තියාගන්න පුතාලා ඔයගොල්ලෝ මේ first structured essay එක තමයි මේ practice වෙන්නේ. right? 2024 A levels first structured essay එකට මේක කියන්නේ. මේ වගේ question එකක් කියන්නේ. guarantee කරලා කියන්න පුළුවන්. right? So then you have checked the answers. So let's go to the 2019 paper, right? Without wasting the time. So again, the first 2 questions we have to do. I'll give the same time, right? Then SO3 F2, one economic structure any question sticker, and then they have given a structure. Most stable right? Draw 2 more dot dash structures. Now main question. Okay, please complete it soon. I'll give only 2 minutes. And okay, so I'm going to check the answers, right? So then these are the answers for 2019 question. So then check your answers. I think manage the answers with this. We have discussed it soon. So this is the most stable structure for F3, and then there are two structures. So the first one is stable, right? And then this one is unstable because the oxygen gets positive charge, right? So since oxygen is getting positive charge, that's unstable. So what you have to do, you can change the pi bond from here to here, and you can change the pi bond from here to here. So then you'll be getting two structures from the given most stable structure, right? So 4 marks for this and 4 marks for this. So you can see the question has a very, simple idea to realize, right? So this is 2019 level. Would you believe this, right? 2019 වෙනවා. ඒ කියන්නේ එන්නේ ලොවි ස්ට්‍රක්චර් ක්වෙස්චන් එක ලේසි වෙලා තියෙන්නේ. ඉස්සරට වැඩිය දැන් ලේසි. නැද්ද බලන්න. මම කියන එක බොරුද බලන්න. Right? And 2012 එක කොහමද? 16 එක කොහමද? Right? This is 2019. And මේකෙන් පස්සේ ලොවි ස්ට්‍රක්චර්ස් අහනවාද? අහන්නේ මෙහෙම. They will be given the Lewis structure and they are asking a table question. මොනවද table එකේ අහන්නේ? Pressure pairs, electron pair geometry, shape and hybridization. දැන් ඔය ටික බලන්න. Right? So then they are pointing out the atoms, and then for each and every atom, they have given the structure. They have given a new structure. Using that structure, you have to fill the table, and they will be giving 16 marks for that. Is it clear? Right? So if you know the hybridization part, then you can do this one also very simply, because these hybridizations you have to allocate for each and every bond in the next part. Right? May bond eකට allocate කරන්න තියෙන්නේ. ඒක බාරලෙස්. Right? මේ part එක. මම කරලා පෙන්නන්නම්. Right? So then very simple. Right? This case. So the question is over, then as a small part from content numbers, you know this one, right? The first question still, right? And then we are moving to the second question there. So is it clear? That's a 19 question. Raise your hands. It's okay with you? Right, okay. 1 minute. I'll show 2020 question also, so you can do it at home. So this is 2020 A-level question, right? Please take a screenshot of this, right? You have to do it, right? 2020 A-level question. The tutor is available in your WhatsApp group. එතනත් අර දෙමනේ තියෙන්නේ. බලන්න. More acceptable එක අඳිනවා. This is draw 3 more Lewis structures for this eye. මේකටම Lewis structures තුනක් අහනවා. Less stable and unstable you have to mark. මේක answers බලලා වැඩක් නෑ අඳින්න නැතුව, right? You have to draw it. I'll add the answers to your WhatsApp group, right? And then here that table. So now try to complete the entire question. මේ දෙක පුළුවන් නේ හොඳට. මේ ඉතුරු ටිකත් complete කරන්න. මේකත් complete කළා. හරි මේ part එකත් complete කරන්න. දැන් මෙතනදී මොකක්ද මේ කරන්න තියෙන්නේ, right? So here you have to mention the sigma bonds. Like chlorine ගේ hybridization එක මෙතනින් mention කරන්න. N1 ගේ hybridization එක මෙතනින් mention කරන්න. So sigma bonds are formed by hybridized orbitals. If they are asking pi bonds, you have to write atomic orbitals. මම මේ pi bonds case එක explain කරන්න next week, right? ඒ ගැන හිතන්න. pi bonds case එක explain කරන්න. මේවා ලේසි අර nothing. දෙයක් ඇත්තම නැහැ. පොඩ්ඩක්වත් බය වෙන්න එපා ඒක. Right? ඒ ටික පුළුවන් මේ first two parts පුළුවන් නම් Lewis structure එක ගොඩ. Right? 2021 question එකක් පෙන්නනද screenshot එකක් ගන්නවද? ඒක ටියුට් එකේ නැහැ. ඉතින් මම පෙන්නන්නට ගාලා. මොකද උඩ ගෙදරදී කරන්න පුළුවන් නේ. 21 structure essay paper. හරි. වෙන 2021 තාම 22 levels තියලත් නැහැ. ඒ තමයි latest paper එක ඔයගොල්ලෝ දැන් අපේ දැනට තියෙන. මේ තියෙන 21 level question එක. Draw the most acceptable Lewis structure for the molecule Cl2O4. ඊට පස්සේ oxidation state of two chlorine atoms drawn in one above label කියලා අහලා තියෙනවා. හරි. පොඩක් කෙනෙක් screenshot එකක් ගන්න පුළුවන් විදිහට question එක arrange කරා. හරි දැන් පුළුවන්. මෙතන ලියාගම 21 කියලා. 2021. So please complete this question also. And give the mark scheme answers. So please take a screenshot. Try to complete them. So on the confidence එකක් හැදෙනවා 12 කරා 13 කරා 14 කරා 16 කරා 15 විතරයි මම skip කරේ. දෙක latest තියෙන නිසා skip කරේ. 17 18 19 20 21. මේ 21 වල ඉතුරු part එක. Right? අර table part එක. ඔන්න එකත් ගන්න. This is the next part. Right? I discussed this one completely. මම මේක question එක completely discuss කරන්න, especially how to get the answers for this one, right? ඒව එකක් ගන්න හැටි ඕනේ කියලා දෙන්න එපා. Okay, question එකක් කරාම මේ ටික ඔක්කොම clear කරන්න ඕනේ. Right? Nothing. So I can add the marking scheme answers, so then you can point out on the answers and check them. Right, okay. So I'll add term test questions. We have Devi Balika and Royal College term test questions. So for this Lewis structure, so then try to do them. Then Lewis structures වලට ආස කරන්න. ඒ ගැන questions කරන්න. කොහොමද shapes? පටන් ගත්තේ කොහොමද අදින්නේ කොතනද? Right? So you have try to have a confidence on this lesson. Then මේකට ආසෙ හිතුනම තව questions කරන්න පුළුවන්. ඒකට අපිට මේ lesson එක පුළුවන්. That's the secret. Okay? So I think ඔයගොල්ලෝ start කරන ඔයගොල්ලෝගේ අලුත් life එක නැත්නම් අලුත් science life එක maths life එක හොඳට හරි enjoy කරගෙන ඕන කමින් කරන්න dedication එක තියෙනවා නම් ඕන දෙයක් පුළුවන් ආසාව තියෙනවා නම් ඕන දෙයක් පුළුවන් බය වෙන්න එපා හරි මොන හරි ප්‍රශ්නයක් තිබ්බොත් මගෙන් support එක ගන්න මටත් කතා කරන්න මටත් WhatsApp කරන්න මම උදව් කරන්න so good night thank you very much